Hey guys, I'm Yikun, and today we'll basically be going over my project, which is on liver disorders and alcohol. So basically my liver disorders data set, what it is it has 345 patients with 7 attributes each. 5 of them describe blood tests that are thought to be sensitive to liver disorders. So if you have a high number in your blood test or a higher than average count, then this might be a sign that it's liver disorder that might occur. And then there's the 6th row that's drinks, and then the 7th row is really just they included it as a splitting of testing and training data sets. So basically what the whole objective of this project is to study the relationship between liver disorder and alcohol. Specifically, what we want to do is to look at the results of the blood test, and if you can tell that slightly elevated amounts of these chemicals in your blood test, then if these are results of higher alcohol consumption, and if it is, we can hopefully suggest to patients that they might want to reduce their alcohol intake, as continuing this might eventually lead to liver disorders. Okay, so right here what you can see is how I explore the data. So most of these data points, the first thing I did was take out the 7th row of the training and testing, because I'm going to split it a different way into training and testing data sets later. So you can see you have 6 variables, which include MCV, ALCA, PHOS, SGPT, SGOT, gamma GT, and the number of drinks. So the first thing we did was make a parastop panel, which allows you to see the histograms. So if you look at this, it seems mostly normally distributed, at least the first 4 variables. Then the gamma GT and the drinks seem to not be normal. So what we did then is just basically make another just a histogram by itself so you can see better. What you can see is that there's definitely not normally distributed, as it's very right skewed. So this definitely does not look like a normal distribution. You look at the collinearity and see if there's any relationships between the variables. So you can see here that SGPT and SGOT is the only one that has a really high correlation of 0.74. Now later, because one of the models I'll be building is logistic regression, this could definitely impact it. However, I believe in the final model those 2 variables were eliminated as they were not significant, so this did not really affect my model too much. Okay, so basically for me to get the data to work, what I first needed to do was create a new feature. Because we were looking at excessive alcohol, the number of drinks is pretty vague. It doesn't really tell you whether there's a lot or a little. So we, instead of having a numeric variable, we created basically a boolean where if the drinks were greater than 5, and the number was picked 5, because from looking online at papers that use this data set, they picked greater than 5 as excess alcohol. So then what we did was we transformed the liver parse, which is the data with the 7th row removed. So you can see here, this is the liver parse data. And then what we did is create a variable called excess alcohol, where it basically creates a factor with 2 levels, where you have false and true, and this is basically true if your drinks are greater than 5. And then what we did is to bind that variable, where we remove the 6th variable, which is the drinks, and replaced it with the excess alcohol. So you can see here, liver full, that here's your 5 blood tests, and then here's a new variable, excess alcohol. So the next transformation we did was basically normalize the data. So here I normalized it via min-max, so here you can run it, normalize, that's your function, and then we'll create a data called liver norm where we store the normalized values. So I applied the normalize into my liver full data, and that normalizes my numeric variable. So when I run this and click on the liver norm, you can see all the values are now in between 0. So the next step is to talk about what types of models I built and why. So basically what my independent variables are basically numeric variables, and then my dependent variable was categorical, basically a factor with 2 levels, true and false. So some of the machine learning models we learned that I thought would work really well would be logistic regression, which is regression, but the dependent variable generally is 2 classes, and then I used KNN as that works well with numeric independent variables, and SVM because we want to create a hyperplane that splits basically true or false for excess alcohol based on our liver data. So what we then do is build these models. Okay, so now we want to see how well these models perform. So let's first look at the KNN. So here I built a KNN model with my training data as my train, testing data as my test, and then I set just picked K as 10, and then I ran it, and then here you can see my model is right now it's just outputting my excess alcohol predictions for my testing data. So then my logistic regression model, the first thing I did was basically plug in all 5 blood test variables into my model to predict my excess alcohol. So you can see here there's basically a lot of variables that are not significant, so I use backwards elimination. And then eventually I created my final model, liver log RF, which basically shows that you just have 2 variables left, MCV and gamma GTUs, to predict excess alcohol. So then my SVM model, I used the KernLab package, and I built my SVM model where so I'll run this model, and then SVM model, it sets the default parameters, and then we can just take a look at the model itself. So here you can see that just looking at it, this probably doesn't seem like a great model. There seems to be 176 support vectors, and my data set definitely did not have that, only had around maybe 250 something data points. So this is clearly a lot of support vectors for that many points. There was a pretty high training error, and there's also likely a lot of overfitting. The model itself, I used a vanilla dot function, so clearly this model, just from looking at it, was not very strong, or probably didn't have a lot of predictive power either. So then the next thing I want to look at was basically evaluate the model. So one way I did that is to see how well they predicted with the training and the test data. So for example, I compared my liver KNN to the actual test data. Here you can see there was about 65 out of 86 correct predictions, so that gets you to about 77%, which is okay. It's not great. Then I did the same thing with logistic regression, and then this had about an accuracy of 79%. So then I used k-fold cross-validation to look at my SVM. So here you can see some kappa numbers that I produced, and then in the end it was not super accurate. I took the average. I only got about 0.32, which is well under 0.5. So this probably says, as we suspected, the SEM model was not very useful or strong. So definitely when we tune and evaluate the model, we'll need to basically make adjustments. And so right now, after tuning the model, I tuned the model, so I manipulated K for KNN, for example, and SEM I manipulated C. So after the manipulation, I tried using the new models to predict my results. My SEM got 71% of the testing data predictions correct, which is okay. Actually, it's really hoping for a lot better, but since we knew that the original model wasn't very strong, it was very unlikely to perform well. So then I did the same thing with my KNN and logistic regression model, and they both had the same accuracy of 79%, which is okay. It's not great. So overall, these models seemed okay. The SVM model didn't seem very good, and it seemed very overfitted due to the number of support vectors. And then my logistic regression and KNN performed better, but they were only moderately okay. It wasn't a particularly strong model or anything like that. Okay. Alright, so from looking at the summary of the models and the projects, so overall it looks like the SVM model did not perform very well, as there was too many support vectors. It had a low kappa value, and it very likely overfit, while logistic regression and KNN only performed moderately well in predicting whether a patient had excess alcohol consumption depending on their blood tests for liver disorder. So while we were hoping to build model using blood tests to predict excess alcohol consumption or not, one problem with that is obviously if you do research on liver disorders, you realize that there are many factors that can cause liver disorders, leading to these elevated levels in blood tests. So basically, for example, some factors might include if you have an infection, any autoimmune diseases, genetics as a whole, and then any behaviors such as sharing needles. These can all cause liver disorders and lead to a high level of chemicals found in your blood test, and these are factors that cause these elevations in your blood test that's not dependent on alcohol. So while these blood tests might be potentially useful in identifying alcohol as something that is affecting these high levels of liver disorders and these high levels of blood tests, doctors should be aware, or whoever uses this information should be aware, that alcohol is not the only cause of liver disorder.